Hi, my name is Anuraj Agarwal. My registration number is 19BC 2026. My topic is Compton Effect. Compton Effect. It was first introduced by Arthur Holly Compton in 1923, for which he received 1927 Nobel Prize in Physics. Later, his graduate student Y.H. Wu later verified the effect. So what is Compton effect? Compton effect is the result of high energy photon colliding with a target which releases loosely bound electrons from the outer shell of the atom or molecule. The scattered radiation experiences a wavelength, a shift of wavelength that cannot be explained in terms of classical wave theory, thus lending support to Einstein's photon theory. Probably the most important implication of the effect is that it showed light could not be fully explained according to wave theory. Applications. So Compton effect has many applications. Compton scattering is of prime importance to radiobiology, as it happens to be the most probable interaction of high energy X-rays with atomic nuclei in living beings and is applied in radiation therapy. In material physics, Compton scattering can be used to probe the wave function of the electrons in matter in the momentum representation. Compton scattering is also is prime importance in gamma spectroscopy, which gives rise to Compton edge, as it is possible for the gamma rays to scatter out of the detectors used. So Compton effect is used to counteract that effect. So how Compton scattering was initiated? It was a Compton experiment in which a graphite target was bombarded with monochromatic X-rays, and the wavelength of the scattered radiation was measured with a rotating crystal spectrometer. The intensity determined by a movable ionization chamber that generated a current proportional to the X-ray intensity. Compton measured the dependence of the scattered X-ray intensity on wavelength at three different scattering angles of 45 degree, 90 degree and 135 degree. The experimental intensity versus wavelength plots observed by the Compton for the three scattering angles show two peaks, one at the wavelength of the incident X-rays and one at the longer wavelength lambda dash. You can see in the graphs. So how Compton effect works? For that I have derived on a paper. You can show that.
Yeah. So here's the derivation. Compton effect. Derivation. So here's the diagram of the experiment. The photon collides with the electron. The scattered photon gets reflected at an angle theta, and the scattered electron gets reflected at an angle of phi, x direction and y direction. So we will take E is equals to h mu, that's also hc by lambda, and we take momentum as E by c. So applying the law of conservation of momentum along x-axis, px initial is equals to px final. So p plus 0 is equals to p dash cos theta plus pe cos phi. That's the equation 1. And along y-axis, while conserving the law of conservation of momentum, py initial is equals to py final. So 0 plus 0, as there is no momentum in the initial state, is equals to p dash sin theta minus pe sin phi. That's equation 2. Taking 1 and 2, we get pe cos phi is equals to p minus p dash cos theta, and pe sin phi is equals to p dash sin theta. By squaring and adding both equation 1 and 2, we get pe square is equals to p square plus p dash square minus 2p p dash cos theta. Now applying the second law of conservation of momentum of energy. Energy in the initial state is equals to energy in the final state. E is equals to mass, the rest mass, the mass of the electron into c square is equals to E dash plus EE. That's equation 3. According to the theory of relativity, we know that EE square is equals to c square PE square plus ME square c to the power 4. Now squaring the third equation and substituting the value of PE square, we get E plus ME c square minus E dash to the power of whole square, c square p brackets p square plus p dash square minus 2pp dash cos theta plus me square c4. Now after calculating and simplifying that, you can see in the equations, and so we get that E minus E dash upon E dash is equals to 1 minus cos theta me c square. So after simplifying more, 1 upon e dash minus 1 upon e is equals to 1 minus cos theta upon me c square. This is known as Compton's scattering formula. We can substitute e as hc by lambda, and then we get lambda dash minus lambda is equals to h by mec 1 minus cos theta. So here the lambda dash minus lambda is known as Compton shift. That's noted as lambda dash. Delta lambda. Lambda is the wavelength of the incident photon, and lambda dash is the wavelength of the scattered photon. The lambda dash will be greater than lambda because its give out energy and its wavelength increases. Here also h upon me ec is known as Compton wavelength. So here's the derivation. That's all I can say about Compton effect. So I conclude my video here.